Yes, you read it right. Today I'm going to talk about a mask which can be sanitized within 2 minutes of sun exposure. It's very easy. I'll try to keep it as simple as possible so that you are also able to understand it. So please watch this video till the end. If you are new to our channel, please subscribe and hit the bell icon for receiving latest updates on exams, research positions, and guidance videos. So let's start the video. Not just India but whole world is facing a crisis for the shortage of masks, the high quality masks, because we have a limited production of this. This brings us to the question that can we have recyclable and reusable masks? So in this regard, scientists, researchers and of course engineers have been working. So today I'm going to talk about a mask which can be sanitized within 2 minutes of sun exposure. This modification can actually be done on commercially available masks. So commercially available masks faces a serious issues, like although they have been coated with hydrophobic materials that are made to repel the water droplets, but it is seen that the water droplets very frequently adhere to them. Like if you see in this image, the contact angle is about 110 degrees. Although this is considered to be a good hydrophobic material, but it is not good enough to protect you from dangerous viruses. Hydrophobic functionalization is a well-established technique which can be utilized in order to prevent the adhering of water droplets on a surface. So this was actually inspired by nature, where if you have seen a lotus leaves, if you try to keep it wet, it will repel the water droplets above. You can also see this in this video where this is actually repelling the water molecules. So the researchers chose graphene. Graphene, of course, is very useful in a lot of things, and it has a very wide application in a lot of things. In order to get the super hydrophobic material on the commercially available mask, we need to functionalize the commercially available mask with graphene layers. So this was done using a dual mode laser induced forward transfer process of graphene onto those commercially available masks. So this actually uses the concepts of nanostructures on hydrophobic materials, which gives us a more super hydrophobic material. Okay, and this is what has been utilized in this research paper. So in these SEM images, you can clearly differentiate the nanostructures present on the commercially available masks, that those are made of graphene, which is the reason of its super hydrophobic nature. The hydrophobic nature in case of commercially available masks come from the polypropylene layer on the fibers. Also, you can see that the contact angle in case of super hydrophobic graphene coated mask is about 140 with respect to the commercial available masks, which just have a angle about 110, which is not enough to stop the frequent adhesion of water droplets onto the mask. So the obvious question now is, why is graphene chosen? The graphene have an intrinsic antibacterial property which can be exploited in these materials. Other than that, you can also see that graphene coated material can absorb a radiation in wide range with a high intensity. So it increases the absorption as well. The highlight of this mask is its ability to get self-sanitized when exposed to sun for hardly 2 minutes. The question is, how is it able to do it? The answer to it lies in the fact that it has a high absorption, and the graphene which has been coated on the outside of the mask is able to increase its temperature from like room temperature to about 70 to 80 degrees Celsius within a few seconds. Like it can raise its temperature from 25 to 70 degrees within 40 seconds and about 80 degrees within just 100 seconds. So this temperature is good enough to get rid of your dangerous viruses, and that is how it is able to sanitize itself. The reason why I particularly like this paper, and you may also like it, that researchers not only thought about making masks which are reusable, but they also thought about what if the masks are used like enough times and now it needs to be thrown. what else can I do with this material? So they constructed this mask so that it can, after this pandemic and all these things, it can be utilized to do solar driven desalination of water, or even if you see the performance, it was able to perform much better than the commercially available polyamide membranes which are used for desalination of seawater. I think this example is good enough to tell you how important are ideas and how important it is to transform the research what you do in lab to the application in the society. So if you like this video, please hit the like button. It takes a lot to make these videos, and do share it with your friends so that they are also able to innovate new things, bring new engineering devices which can be beneficial in this situation. Thank you so much, Inspire Chemistry.